Good evening. We were tasked to solve a differential equation connecting to our respective courses. I'm an ECE student, which stands for Electronics and Communications Engineering, and we handle circuits. Now, with the given RL circuit diagram, there are values in the circuit for the voltage source, resistor, and inductor. Voltage source is equal to 10 volts, the resistor is equal to 5 ohms, and the inductor is equal to 1 Hz. The problem is, in the given circuit, find I, noted as the current flowing in the circuit, using differential equations. We can look for I by solving it using KVL. Now, we apply a clockwise rotation inside the circuit. The voltage source has positive and negative polarity. So the current enters from here, rotating here and here. So he enters at the negative polarity. So that is why it's negative 10 volts. And he enters the resistor, which has positive polarity, so it's plus 5I. So now, voltage drop along the inductor is equals to L di over dt. And the current enters in a positive polarity. So it is plus L di over dt is equals to 0. Now, we know that L equals to 1. So, rewriting the equation, it would be negative 10 volts plus 5I plus di over dt equals to 0. Now, we need to transpose negative 10 volts, so we will have any negative value. So, the equation would be di over dt plus 5I equals to 10. Notice that it is a differential equation. It is a linear differential equation. And we know that if it is linear differential equation, we need to find for its integrating factor. To solve for its integrating factor, it is equal to mu of t is equals to e power of integrate 5 dt. E equals to 5t. Mu of t is equals to 5t. Now, we have our integrating factor. Then we multiply this to our differential equation. Now, e to the 5t, okay, di over dt plus 5I equals to 10. And we have our new equation, which is equal to e to the 5t di over dt plus e to the 5t 5I plus 10 equals to e to the 5t. Now we know that the linear ODE can be transformed into d over dt and times its integrating factor e to the 5t times I is equal to 10 e to the 5t. Now, we need to integrate both sides. Integrate, and we would get e to the 5t I is equals to 10 times e to the 5t over 5 plus c. Now, we're looking for I. I'm sorry, it's smaller I. Now we're looking for I. How are we going to do this? To do this, we need to divide e to the 5t from both sides. So I is equals to 2 2 plus c over e to the 5t. Now we have our I, which is the current flowing from the current. So, which means I is equals to 2 plus c over e to the 5t amperes. Now we have it. We have our differential equation. Thanks to our differential equation, we have our I. Thanks for watching. I hope you enjoy it. Thank you. Goodbye.